So you have V total is going to equal, well, again, you have here 3 goes into there 3 times 6 times 10 to the 5th. And then this one, you're going to have 2 goes into there twice. 2 times 9 is 18, so negative 18 times 10 to the 5th. And if you factor out 6 minus 18, that's going to be negative 12 times 10 to the 5th, and this is units of volts. So the total potential is going to be negative 12, 0, 0, 0, 0, 0. Okay, volts. That's a lot of voltage. So negative 1,200,000 volts, or the other way you can say it is negative, and this 3 zeros is a kilovolt, negative 1,200 kilovolts. That's going to be 1,200 kilovolts potential. Okay. Now some people might think, oh my gosh, that's going to kill you. Well, it's actually not voltage that really kills you, it's the voltage difference. So if you happen to be, for example, let's say you happen to be a rod that extends 1 meter, okay, between 3,0 and 4,0. Okay. Let's say there is an uncharged rod there, but let's say there's a conducting rod. Then there's going to be a potential difference between the two ends of the rod, and then that's going to create a lot of current through the rod. That current through the rod is going to actually heat up the rod. So it's not potential that heats it up, but it's potential difference that causes current, and then that current heats up the rod. So we could ask a question such as this. If the resistance of the rod is 100 ohms, or we could say it could be 100 kilo ohms, okay, 100 kilo ohms, what would be the current in the rod? The current in the rod. So what we would have to do, we would have to find the potential at 4,0, and 3,0 we already know, and we take the difference of that. Okay? So what would be the potential at 4,0? The potential at 4,0 would be what? 9 times 10 to the 9th, and it'll be 2 times 10 to the minus 4 divided by 4 meters, right? Because we're at 4 over here, plus, then you put here negative 4 times 10 to the minus 4 over 1, since this one is 1 meter away on this side. So then you're going to have V of 40. So you're going to have 2 is going to cancel the 4. Then you're going to have 9 divided by 4 is 4.5 times 10 to the 5th. Plus, and then what is this? 9 minus 4. So that's simply just negative 36. Negative 36 times 10 to the 5th. Okay, so what is that going to be? 4.5 minus 36. 4.5 minus 36. So negative 31.5 times 10 to the 5th, which is what? Negative 31, and then you have 5,0,0,0,0. So you go, the decimal point goes over 5 times. So now how many kilovolts is that? V of 40, negative 3,150 kilovolts. Okay, so the potential over here would be negative 3,150 kilovolts. The potential over here was what? Negative 1,200 kilovolts. You take the difference of that, right? 3,150 minus 1,200. So if this is negative 1,200 and this is negative 3,150, the difference is 1950 kilovolts. 1950 kilovolts. Now I can say, okay, the resistance of the rod is 100 kilovolts. What's the current? The current is the change in voltage divided by resistance. 1950 kilovolts divided by 100 kilovolts. Cancel, cancel. and you end up having 19.5 amps. So the current is going to be, because the kilos cancel, 19.5 amps. Okay? So you can kind of see, we flavored it up a little bit. We put a rod, we took the potential at those 2 points, took the difference, and then from there got the current. Now let's answer the last question. What is the total potential energy of these two charge system? In order to answer that question, the potential energy, also sometimes written as U, is K Q1 Q2 over the distance between them. We can call it R, or we can just call it D. This kind of problem, you're finding their potential energy of the system, so you're not finding it at a certain point. Basically, it's the potential energy of the two together. So you have to take the product of their charges, 9 times 10 to the 9th, times the 2 times 10 to the minus 4, times negative 4 times 10 to the minus 4, divided by the distance between them, which is 5 meters. Okay, so again, you're going to have to put the sign of the charge, which is negative. The other charge is positive. So you get here 18. 18 times 4 is what? 72. Negative 72 over 5 times what? 10 to the 5, 10 to the minus 4 is equal to what? Just 10. 10 to the 1, right? So then you have negative what? Well, 5 goes into 72. 14 times, right? 14 times 5 is 70 with 2 left over. 2/5 is 4. Times 10, so that's equal to negative 144 joules. Okay? So the potential energy of the system is negative 144 joules. What does that mean? That means the two charges like being together. Things like to be at negative potential energy. In order to separate them apart, how much work would we have to put in? In order to separate the two charges, since one is positive, one is negative, we're going to have to put in work to separate them. How much work? 144 joules of work to separate the two charges so that they go out to infinity from each other, okay? That's called the ionization energy. So now you can see how to do these kinds of problems. Thank you very much.